Hello. Crop and plant health are directly connected to soil and substrate health. Would you say you know what it means? How many beneficial soil microbes would you be able to name? Joke aside, my name is Nicolas Body. I am technical manager at Altec Crop Science in Europe, and my specialty is the soil microbiome. I want to explore some of the roles of beneficial microbes in building a strong foundation for plant health and introduce our Contribute SR solution for horticulture growers in the UK. We see a lot of issues in crop and horticulture production connected to soil health, root health and soil-borne disease, soil fatigue and overall lack of performance from plants that have been bred to have great genetic potential. Is simply over-farming exhausting our soil in every case? Let's look at some healthy soils. Research found that in urban gardens in the UK, they have better soils than farmland. They have more organic carbon, better carbon-nitrogen ratios, and more available nutrients. A little further, despite being the birthplace of agriculture and despite thousands of years of cultivation, the floodplains of today's Iraq are still fertile. What is their secret? What are the characteristics of a healthy soil is the question I'm asking. So let's break down together the component of a healthy soil in a productive sense, a soil able to withstand a great and healthy plant for a great harvest or production. First, a balanced profile. This shouldn't be new to you, but soil and even more substrate is productive if it is balanced. In a soil, minerals should be accounted for about 50%, while the rest should be shared between air and water and the very important organic matter. The second characteristic of a healthy soil is its characteristic in terms of type of soil. The most productive soils in the world are silty or loamy soil with high organic content that is combined with good aeration. That will bring a good retention of water and nutrient. On the other end, we've got two opposites with clay soils that are able to store water and nutrients but will be poorly aerated, and sandy soils with good aeration but very little capacity to hold water or nutrients. pH is also a key factor of a productive soil in the sense that it will be influencing the availability of nutrients in the soil, and therefore the natural fertility of the soil and the efficiency of the fertilizers that will be applied. Once again, it shouldn't be a surprise to you. But the third part and the third key characteristic of productive soils is actually the one I want you to get your attention towards. I'm speaking about the microbiome. This is what makes the healthy and productive soil different, the amount and the diversity of the microbes in the soil. Millions of bacteria and fungi per gram of soil. More microbes in a handful of soil than there is humans on the planet. And you see, I mean, today in the ag news that measuring the microbes in the soil, the beneficial as well as the pathogen, is becoming more and more common, and we will see that in every part of the world. Let's take a few examples, like illustrating some of the most known symbiotic relationship between microbes and plants in the soil. Rhizobium. On all the legumes, such as soybean, beans, lucerne, or alfalfa, the beneficial bacteria are forming nodules to absorb nitrogen from the air, making it available for the plant. Another example, Trichoderma, a fungus, can form a protective layer around the roots of plants and as a consequence protect it from pathogens as well as increasing the area, the volume of the rhizosphere. Both of these examples have been known for a long time, and the fact that they are visible to the naked eye is the main reason. When I'm listing these regions, do they speak to you in the Canary Island, the Salinas Valley, the Broye Valley, and the Château-Renard region in France, not far from where I am today? They have something in common. They have little to no soil disease. These soils are quite famous among soil microbiologists because they have unique properties. In these regions, you can find what is called suppressive soils. In these soils, even an inoculated pathogen will not find a way to affect the plant. This picture is from an article by the University of Wageningen in the Netherlands, where Rhizobacteria, a soil-borne pathogen, is introduced to either a conductive on the right or a suppressive soil on the left, and sugar beet seedlings were grown. The soil-borne disease does not affect the plant in a suppressive soil, where we see that the seedlings are quickly dying in a conductive soil. After analyzing the soils from such a sugar beet field that had become resistant to pathogens that cause root fungus, the scientists found that 17 soil microbes were fighting to suppress the pathogens. They also determined that all of the microbes work together to reduce the incidence of the fungal infection. Their discovery showed that plants use a tight-knit army of soil microbes for defense. There is a bad news. If you sterilize such a suppressive soil, then you lose that characteristic right away as you kill those microbes. But there is a good news. You can transfer that characteristic by inoculating 0.1 to 10% of a suppressive soil into a conductive soil. You can establish the disease suppression and transfer that characteristic to the new soil. And that's very interesting. What if we could grow these microbes, the microbes from these suppressive soils? Isn't that time to invest in those microbes? It is, actually, and it has been for many of the big ag companies for the last decades, as they invested in research or production facilities in companies that were specialized in microbial solutions derived from microbes. And Altec has been doing this for 25 years now, when Altec launched its ImproCrop division, now known as Altec Crop Science. Altec Crop Science is a global leader in natural solutions derived from microbes, bringing proven and effective solutions to solve today's agronomic challenges in the soil, the plant, or the environment. Altec was founded in 1980, just outside of Lexington, Kentucky, in the USA, by Dr. Pierce Lyons, and today working in more than 120 countries, still privately held and managed by Mark Lyons, Pierce Lyons' son. And Altec is a leader in research in those microorganisms and also in the production of them to support sustainable farmers' sustainable productions. So what are microbial inoculant? The definition is quite easy. It's a living microorganism that will be applied to the plant or the soil or even substrate. They are beneficial microbes and they can form relationship with the plant and aid in the plant development. We speak about PJPR, plant growth promoting rhizobacteria, for some of them, and their main function is for the plant growth and health. Some of the interesting microbes that we can use as inoculant and under intense research, as they have been found in these suppressive soils or very healthy soil around the world, the ones we mentioned earlier. We have Bacillus subtilis, a plant growth promoting bacteria that will increase mineral uptake and be antagonist against a wide variety of soil pathogens. We have Enterococcus faecium that will be interesting and useful for breaking down plant residues and organic molecules. It also suppresses pathogens by reducing the oxygen and raising the pH of the soil. Also Lactobacillus plantarum that produce lactic acid that can suppress competing microorganisms in its environment. And from these microbes, some bactericides have been found. Other quite common inoculant nowadays, Trichoderma asianum is the most known. It's a fungus that can create a symbiotic relationship with the plant roots. Also, Pseudomonas fluorescens for growth promotion, and the very famous Rhizobium japonicum involved in making nitrogen available for legumes. If you want to learn more about these, I highly recommend you to connect to our website and to check our discovery series about soil health and about inoculant to learn more about what they can do and the research behind this. Let's look a little bit at one of the most interesting thing with inoculation of bacteria to the plant. That's the capacity to promote the plant growth. It is done through two modes of action: the stimulation of the root growth, where the bacteria is sending messages to the plant, also reacting to the exudates from the plant roots, but basically telling the plant that's a great environment to grow new roots. And also by making nutrients bioavailable for the plant, extracting nutrient from either the rock or the mineral or the organic molecules that are in the soil not readily available for the plant. Inoculation of microorganisms is also a great practice in order to prevent or reduce the incidence of soil disease from the soil. The beneficial microbes can play a role as antagonists, taking room in the soil jungle, or even through parasitism or predation. Another mode of action is connected to the induction of resistance to the plant. And also the fact that some of these inoculants can reduce the amount of soil-borne pathogens that will go from one crop to the next by accelerating the decomposition of the crop residues, often where the pathogens overwinter or transition from one crop to the next. So from these general information about soil health and microbes and where the discoveries and the science and the research is coming from on this, I want to introduce our own Contribute SR solution, SR for soil revitalization. This is the most complete biostimulant on the market and has been launched to the horticulture market in the UK with ICL. It's a product that is composed of selected microorganisms and enzymes to balance the microbiome of the substrate or the soil. It contains 3 microbial strains and also enzymes. The strains of bacteria are Lactobacillus plantarum, Bacillus subtilis, and Enterococcus faecium. plus these enzymes that will be able to break down organic molecules on their own and kick in the start of the product, of the efficacy of the product. Contribute SR is supplying 3 live microbial strains, and they have been selected for their role in healthy, balanced soil and the root environment. The live microbes in Contribute SR will help break down organic molecules from the substrate, as well as the previous crops, previous crop residues, or even organic fertilizers. By improving the soil carbon and the pH, they will promote a balanced root structure and environment. And the plant will thrive in this balanced soil and substrate that Contribute SR helps create, with a robust population of beneficial microbes. And these are quite known as plant growth promoting bacteria. And if you take the example of Bacillus subtilis, it is known to stimulate the growth of plants, but also the Bacillus family of bacteria is playing a key role in healthy soil, being at the interaction between soil and plants, but also plants and other microorganisms, and soil and other microorganisms. Some of the mode of action of these microbes that are quite interesting is the capacity to form a biofilm around the roots, meaning a very densely populated region of the root system with a lot of these beneficial microbes that will increase the surface of interaction with the soil, meaning more interaction with the nutrients of the soil and the fertilizers, but also less direct interaction from a pathogen to the plant. The induction of resistance also plays a role and is connected with Bacillus subtilis. And then the fact that the plant will produce more exudates, being in contact with these beneficial microbes and sending more message for the other microbe to grow, or the other beneficial microbes to start moving towards the rhizosphere. One little word about the enzymes that we've been using. We've been using enzymes mostly that are able to break down protein or carbohydrates so they will start making nutrients available for the beneficial microbes that are in the product and that will colonize the environment later on. I'm leaving you with some references about the different capacities of these microbes. Bacillus subtilis, with the different volatile compound and molecules that are produced by this one, and also from the 2 other that are called fermenting bacteria that are really involved in decomposition of organic molecules and production of organic acids such as lactic acid. The consequence for the plant is first a physical chemical quality around the root system, and that's going to be very true in a substrate or in a soil. And for the plant, the direct impact is going to be the increase of the bioavailability of nutrients, and N, P, and Ks will be increased, but also a lot of the micronutrients. More about the formulation, I mentioned the enzymes, protease, cellulase, and xylulase, but we also bring an energy source as carbohydrate to the product to be sure it's gonna start efficiently, not be lacking any nutrients during the first few steps, while the microbes are waking up and colonizing the root environment. A little bit about the process. We use lyophilization, meaning we freeze dry these microbes, and that's actually the best process of conservation of the organic product, because we want to keep these microbes alive but not sensible to the environment before they arrive to your fields or your greenhouse. So that method is less aggressive. You don't need to keep the Contribute SR bags in the fridge. You can keep them at room temperatures, and they have the greatest viability after that. So basically, we freeze the microorganism, then we evaporate the ice, and we keep the freeze-dried microorganism into the bags that will be rehydrated by yourself, by the farmer, by the producers, and that's where they're gonna be able to wake up and start their inoculation of the environment. So let me look at some of the trial results from around the world. Some example where it can be particularly beneficial on short crops such as lettuce, where the start of the plant and the fact that it is starting with a healthy root system is making all the difference in order to harvest and cut the maximum of lettuce from the field. In this case, one application 10 days before transplanting, which is quite common with Contribute SR on these crops. The situations where this product, along with some of our other solutions, can be very beneficial is in areas where there is a history or risk of diseases from the soil, meaning that the balance of microbes in the soil is less than optimal. In that case, bringing beneficial microbes such as the ones in Contribute SR will fill the room around the root zone and reduce the risk of seeing another start of soil-borne disease such as sclerotinia in that case. In hydroponic production, once again, having a healthy root system with full of beneficial microbes will protect the plant against the potential soil-borne disease that are being in the system, or that may be in the system coming from another crop or another area of the greenhouse. In that case, repeated application every week of Contribute SR. And I've selected some of the trials that may be able to explain to you a little bit of the mode of action or how it can be interesting in horticultural production. I mean, that's not horticulture properly, but in that case, we are working with Contribute SR on organic molecules to be degraded. So in that case, that's poultry litter. And we see that with Contribute SR, we have a steady and interesting reduction of the carbon-nitrogen ratio at 7, 15, and 30 days when we did the analysis, compared to time 0 and time 90 days when it wasn't treated. The key factor here is that below 20 of carbon-nitrogen ratio, we have mostly mineralization, and there is enough nitrogen in the material for microorganisms to break down, to decompose. And if it goes higher, then we have nitrogen immobilization in the media, and then we will see increased production of enzyme that will use the remaining carbon, and that's not where we want to go when we're working with poultry litter or any organic substrate with a high carbon nitrogen ratio. And in the same situation, what we see when we look at the availability of nutrient, we see a better availability of nitrogen quickly released into the plant. I mean, steadily released into the plant, and a better availability of phosphorus as well. I think these pictures from a trial are illustrating quite well how combination of practice, substrate, organic material, and inoculant such as Contribute SR can be beneficial. We're looking at the roots of melon plants 60 days after transplanting. In the control A, we've got no mulching, and we see how the root system is. And then we go to B, mulching, and then more interestingly, on C, we have a cabbage that has been mulched, and we see a lot of root system. And then if we introduce Contribute SR, then we get a greater impact of these two practices, the crop before and the mulching. And even better if the crop before is not a cabbage but beans that have been mulched and inoculated with Contribute SR. So why is it relevant? I mean, that's very comparable to what happens in a peat-free substrate. And the question is just, why is this relevant to you? I'm thinking about peat, and first, peat is agronomically amazing. You have the high organic matter, and you have the beneficial microbes, especially if it's not sterilized. But peat alternatives, such as reduced peat substrate or peat-free substrate, could be as good as natural peat if we can increase the amount of beneficial microbes that are in that environment, and if we can increase the availability of nutrients by quickly degrading the organic molecules of that substrate that are not as readily available as in normal peat. So the conclusion is just when you're moving from peat substrate, 100% peat, to peat alternatives, if you want to expect a result that is as good as the one you're having with peat, then you need to combine it with other practices, and introducing these three microbes that are in Contribute SR is actually a great fit, because they will promote the growth of the plant and they will decompose the organic molecules that are composing the peat alternative in there. And that's my conclusion. I want to thank you for your attention, and feel free to contact me. Thanks.